Greetings everyone. On the bench today I have a product to review. I'll accept the product to review if I think it's something interesting. And I've reviewed a lot of Class D amplifiers before, and I think this is a cut above. Hopefully, I haven't actually tried it yet, but it looks like it might be something a little better than some of the other stuff I reviewed in the past, so I accepted the review and here we are. Now this company, Fosi Audio, I see a lot of their products on YouTube these days. I think they're in the ad campaign to get their name out there. So yeah, let's see what this is all about. What we have here is the BT10 amplifier. Includes the manual. I don't like to go through manuals in a video. It's kind of boring, but that's the manual. Comes with a 32-volt power supply and the amplifier itself. So what we have here, a little larger than some of the amps I reviewed in the past. The ones that were complete in a case, that is. So we have a power switch, looks like a little indicator light there. Treble and bass controls and volume. It's a metal case. Pass QC sticker. Of course, in the back here we have the speaker terminals. Banana plug ready. RCA line ends, and of course power, 18 to 48 volts. I'm glad they're including a power supply and not pushing it all the way to 48 volts. Though you could if you want, but I think it's better when you don't push the product with the highest voltage, highest power possible. So yeah, a little bit conservative in that regard, but kudos to them for doing that. Okay, I got everything hooked up for a little music demo here. I turned the volume down on the camcorder, so I have to talk a bit louder so I can point the camera at the speakers here so you can hear it a little more properly. Hopefully I don't overdrive the camera amp, but the microphones, but yeah, this is supposed to be based on the TPA3255. It says here on this paper it came with the amplifier. Upgraded version, Fosi Audio TB10D, 600 watt. So yeah, we'll see about that. Okay, so everything's hooked up. I don't hear any clicks and pops when I turn it on and off. That's nice. Let's give you a little sound demo here. Okay, what I'll do is adjust the tone controls so you can hear the difference. Treble up. Treble down. Back to mid. Bass up. Bass down. Everything back flat. Okay, noise test. It's a quiet amplifier. Not bad at all. To hear any noise, I have to put my ear up to the speaker. By noise, I mean hiss. I could measure on the scope or anything, but it's just quicker and gives me a good reference compared to other amps just by using the speaker. So it is a quiet amp. That's one thing with a lot of these Class Ds. I noticed they tend to be more hissy than some of them, but this one is a pretty quiet amp. One test I like to do is play unaccompanied piano music, something that's really nicely recorded, and get down close to the speakers, adjust the volume, and just listen to the notes. See if they're clear. Make sure they don't have a fuzziness to them. If it does, you have an issue, some sort of distortion issue. Like with Class A B amps, you can easily hear crossover distortion that way. But this amp, so far I'm pretty impressed. It sounds really good. I really like the contour of these tone controls. When you turn the bass up, it doesn't affect the mids or the lower mids much. It just controls the bass. Okay, so I'm going to subject the amp to a battery of tests as usual. Check the power, frequency response, and all that good stuff. So I have it hooked up to my stereo dummy load, 4 or 8 ohms. We have the music going there. I use the preamp because my little Sony Walkman digital player here, for some reason they limited the outputs to 500 millivolts RMS, so I can't drive the thing all the way into clipping, so I need to use a preamp to help boost the voltage a bit. So anyway, I'll start out with some power tests, see what this thing can do. We'll start out with 8 ohm loads, both channels driven. Okay, 1 kilohertz sine wave. I adjusted it to the max point before clipping. With these Class D amps, you usually get that fuzz at the top and bottom, so it's kind of hard to see where clipping actually starts. But I adjusted it as close as I can, and we're getting 21.31 volts RMS into 8 ohms. Okay, so now I'm checking this with a 4 ohm load, and something interesting happens. It cuts out. I try to get a measurement. Well, I did get a measurement, and it's 93 watts with the supply. So what's cutting out? Is the supply cutting out? Let's see. Yep, the power brick cuts out. This being 32 volts at 5 amps, that's what, 160 watts or so. And figuring in the losses, would be drawing over 200 watts from this thing. So yeah, this can't sustain a 4 ohm load. But I mean, when you're playing music, no problem at all, but with a continuous signal, yeah, it causes this thing to cut out. When I hook this supply up, I can go a little higher with it. I mean, I'm still limited at 32 volts. Both channels paralleled at 3.2 amps or 6.4 total. And yep, the supply went into current limit. So yeah, this thing must go into current limit at around 6 amps or so. But yeah, the amp itself can certainly handle it. Okay, now I'm testing the frequency response. I started at 1K, and the waveform should be touching the graticule here. It flips back and forth because there's a tiny bit of switch mode noise getting through, and that kind of affects it. But all the way down to 20 hertz, it's staying flat. Well, we're at 40 now. Let's go down to 10 hertz. Let's turn that up a little bit. So that's 10 hertz, and it just barely has rolled off. So now we'll crank it up high and see what it does. Okay, so now we're at 10 kilohertz and it's staying flat, and 20 kilohertz. Actually peaked up a little bit. I think we're starting to see a reaction of the coil, the output coils. Let's see what happens at 4 ohms. So it did drop down. Let's go back to 20 kilohertz. Actually, still pretty good. I mean, it dropped down slightly, which would be pretty much imperceivable if you could hear that high, but yeah, it's one issue I noticed with a lot of these Class D amps I tested in the past. The poor frequency response at high frequencies, they'd tend to roll off severely. I mean, they'd be down quite a bit at 10 kilohertz, but this amp is staying pretty flat. And of course, this is the a little bit of the switch mode noise getting through. That's the square wave response. You can't really do this that well with a Class D amp because of the filters that are needed to remove the switch mode frequency. But just so you can see it, that's what it looks like. Adjusting the tone controls here, I'm at 1 kilohertz. The treble, you can see a very, very mild response. The bass control, no response really. I like to see that because the bass and treble controls are not affecting the mid-range. Okay, now I'm looking at the bass control at 200 hertz, and it has a small response. There's some response. Again, I like that because the control is most effective in the lower bass regions. You can see here how the bass control has a very strong effect at 50 hertz. So yeah, the tone controls on this thing are done really well. My distortion testing is unreliable at the moment, but I'm seeing something weird here. That's the fundamental, that's the 4.5 kilohertz pilot signal, which I put into the, the test signal. That's at 1% of the fundamental. We got this weird large peak going on at 4 kilohertz. When I switch it to 4 ohms, watch, it shifts up to like 5.5 kilohertz. So I'm not sure what that is. It must be something to do with the, I don't know, the switch mode frequency change or something. That's an awfully big signal though. So yeah, that's kind of odd. I'm not sure what's going on there. I don't see any distortions to the waveform that would cause that. Say I switched it back to 8, now it shifted a little bit less than the pilot signal. I'll go back to 4 ohms again. And it moves up. Yeah, it's got to be some artifact of the pulse width modulation. Yeah, I turn off the signal source so there's nothing going into the amp, and yeah, that's still there. That's something to do with the pulse width modulation. Yeah, I hooked a speaker up. I should be able to hear a tone that strong pretty easy. And yeah, nothing from the speaker. It must be a ground loop thing, something going on here. So I'm just going to disregard it now. Taking a look inside here, looks like Fosi Audio spins their own boards instead of just using a generic one. Version 2.1. The output filters look substantial. I've run into some of these boards where they use tiny chokes and they get really hot because the wire is really thin. Shouldn't be an issue here. And as we saw earlier, they don't affect the frequency response. So I removed the heatsink, and yeah, it is a TPA3255. I cleaned off the heatsink compound. I'll have to re-grease it when I put it back together. It does have a substantially sized heatsink. That's good to see. Though I wonder how effective it is enclosed like this with no vents. It's not in any physical contact with the casing, so you'd have to radiate or convect the heat to the casing. So at least they did give it a decent sized heatsink. But, that's another reason I wouldn't run the thing with 2 ohm loads. It's a lot of heat in there. Front end of the amplifier uses NE5532 op amps, 4 of them, and there's a little buck regulator there to power those op amps. So they're using 5532s with the 3255. I'd rather have a bottle in front of me than a frontal lobotomy. Well, there you go. And yeah, I don't have any complaints. It seems to be a decently laid out circuit. Another little attention to detail is this pogo pin right here. What that does is ground the casing with the system ground on the board there. You see that rectangular patch in there? That's where they cleared off the coating, so that pogo pin can make contact. Okay, to take a look at the measurements. With the 32 volt supply, 4 ohms, I got 90.3. I retook the measurements. I forgot to put more waveforms on the scope screen, which gives me a more accurate measurement so I can calculate with. 8 ohms, 53.1. At 24 volts, I measured that. It's two 12 volt batteries together. It might be a little higher because 12.6 volts nominal charged of lead acid, but I just used 24 volts. And I also measured at 18 volts. If you have one of those 18 volt bricks, sometimes you can find those. 19 volts as well for laptops. So you're looking at 30 watts into 4 ohms and 17.2 into 8. Idle current at 32 volts is 50 milliamps. Minimum operating supply voltage is 16 volts. As I lowered the voltage, it cut out around 14 volts. Then as I raised the voltage again, it cut in around 15.5. So we'll say around 16 volt is its minimum operating voltage. If you watch my reviews of these amplifiers and amp boards in the past, you know I always have a complaint about something. Either they're too noisy, or the frequency response is not flat. They roll off well too early. I mean, some of them are rolling off severely at 10 kilohertz due to the design of the filters. But this one doesn't suffer from any of those issues. They always fib about the output power rating on these, and that's why we check it here. But you can run this at higher voltage to get more power if you're using 8 ohm speakers, but due to the thermal design, I wouldn't be pushing it with lower impedance loads. I do need to get my distortion measurement situation under control, but I don't think you're going to find any issue with this amp. It sounds really good to me. And as I mentioned earlier, I like the contour of these tone controls. They leave the mid-range frequency band pretty much well alone. That'll do it for my review of the Fosi Audio TB10D Class D amplifier. Pretty happy with this one, and I recommend it. That'll do it for this one. Thanks for watching. I really like the contour of these tone controls. They live blah 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 blah.